Hi, everybody. Good morning. We're going to go ahead and start this webinar. It is 9 o'clock. Thank you so much for joining us. My name is Pauline Esalu, and I will be moderating this live webinar. This is our very first webinar at Habana, so we're super excited to have you here. We welcome all feedback and comments to help us improve in the future, so please feel free to reach out to us after this and let us know how we could improve on our content. This is the Getting Started with Habana Gaudi AI Processor webinar presented by Sri Ganesan, the head of our software products, and Yuting Yang, the lead from the application engineering organization. In this webinar, Sri and Yuting will provide us with an overview of Gaudi, solutions for cloud and data center, go over the developer tools and resources. They're going to provide us with a live demo, and we will conclude with a live Q&A session. But before we get started and we begin, I have some housekeeping notes. Today's session is being recorded and will be made available for later viewing. If you have any questions or have any issues, there's a chat feature at the bottom of the Zoom. Please type it in there and we will get back to you. At the end of the presentation, we do have a live Q&A where you will be able to type in your questions. I'll read them out loud, and then one of our presenters will answer those questions for you. Now, I would like to welcome our presenters and have them introduce themselves. Sri, I'll pass it on to you.
Thank you, Pauline. I'm Sri Ganesan, and I'm the head of software products at Habana Labs. And we have Yuting here. Yuting?
Yuting, you're on mute.
Sorry.
No worries. Welcome, Yuting.
Yeah. Well, good morning, everyone. So my name is Yuting. I'm managing the deep learning training team in a organization in Habana Labs. Thank you for coming.
Thank you all. This is very exciting. Our first webinar, like Pauline said, and we're looking forward to giving you more an overview of Gaudi, and then we'll talk about some of the software enabling aspects, and Yuting will do a live demo for us. Next slide. So today we're going to talk about Gaudi, which has been purpose-built for deep learning training for AI with the goal of advancing compute efficiency. There is a great demand for training, growing demand for training, and 56% of the respondents of a recent IDC study indicated that the cost for training is one of the largest barriers for adoption. Gaudi enables you to move forward with a more cost-efficient solution, and we're hoping we can show you more about how to get started with Gaudi and start leveraging it for more cost-efficient training for your deep learning training needs. So I talked a little bit about it being a purpose-built AI processor. We have three basic tenets that we built it upon. One is cost-efficient AI training. The second is building it for flexibility, so it's easy to use and you can migrate models easily. Software should be the most critical piece here to enable our developers to get started with Gaudi and actually be productive with it. And we've architected both the hardware and software for scalability because it's a very important piece of deep learning training in terms of being able to scale it to a larger number of nodes and get the efficiency from there. So this is a very, very quick overview of the Gaudi architecture. It is a heterogeneous compute architecture. You will see a configurable gem engine and a bunch of fully programmable tensor processing cores, along with obviously a memory hierarchy, which includes 32 gigabytes of HBM2 memory. And at the bottom end, you will see that we have integrated, this is the industry's first integration of native integration of 10 ports of 100 gigabits Ethernet with RDMA, and this is what we are using to scale across devices, and also the same Ethernet protocol is used to scale out across multiple nodes. So basically, you're using industry standard protocols, and no proprietary interfaces are used. This slide talks about basically our software stack, SynapseAl. SynapseAl is built for accelerating deep learning training models on Habana Gaudi. And our goal has been to minimize the number of changes that you have to make to take a model that's already working and then port it over to Gaudi. Yuting will be sharing a little bit about these changes at the end of the talk, where he will actually dive into the demo, and you'll see the kind of changes you'll have to make and how you easily get started. Majority of deep learning developers are using TensorFlow and PyTorch, which are very popular frameworks. So we have integrated SynapseAl with both TensorFlow and PyTorch. And we have our internal proprietary software stack, which includes the graph compiler and runtime, our Habana communication libraries, our very rich kernel library, which are all working together to basically take the recipe, the deep learning computation graph, and generate the optimized solution for running on a Gaudi. And in addition, we have a suite of TPC programming tools, as well as debug and profiling tools. The TPC programming tools will allow you to write custom kernels. For those who want to do that, it's not required because our kernel library is fairly broad and has a pretty large number of performance optimized kernels. But those developers who want to write their own custom kernels can use the TPC programming tools to write their kernels, and then you register it with SynapseAl, so it'll start using your custom kernels as well. In addition to having this software suite available, we are also investing a lot in developing resources to make it easy for developers to access the software stack, be able to use it with a lot of examples, and basically tutorials, videos, how-to guides. We'll touch upon that a little later in this talk. That's our developer site, and we want to make sure it's very simple to get started and have a lot of these self-service examples and resources available for our developers. So we are very excited to be announcing, like you heard about, the Gaudi EC2 DL1 training instances. These are now available, and AWS has announced that this is the best price performance for training deep learning models in the cloud. These AWS DL1 instances have 8 Gaudi processors and have up to 40% better price performance than the latest GPU-based instances. SynapseAI is available. That's on these instances. You can just basically use our SynapseAI software stack. It comes with also, in addition to the deep learning armies and deep learning containers, there are also optimized images for ECS and EKS. And we'll be also integrating with SageMaker very soon. So if you look at the last line, it shows about details about the instance. It's called DL1 24x large. You'll see the details on the vCPUs, the memory, networking. And the price is basically 60% lower than the P4D prices, which have 8 A100 GPUs. So a little bit about the DL1 instances. We talked about having, it has AWS custom Xeon scalable processors. It has 8 Habana Gaudi accelerators, which have the 32 gigabytes HBM, 400 Gbps of networking, 4 terabytes of NVMe storage. And within the single DL1 instance, all of the Gaudi devices are connected with all-to-all with the 100 Gbps interconnect. And obviously SynapseAI is available, and you can use TensorFlow and PyTorch with these instances. And like I said, we have also the TPC programming tools for developing these custom kernels. A variety of use cases are supported today. We have object detection and segmentation, image classification, natural language processing. Here are some of the applications that we're supporting with some of our partners and end customers. And you will see some of our reference models, which you can actually take and start using in these applications immediately and getting benefit from the DL1 cost savings. Here's a simple comparison with 2 examples with ResNet 50 and BERT Large, which show you the cost savings you can get with the DL1 instance compared to the A100 and the V100 instances, the P4D and P3. On ResNet 50, we're able to show get up to 46% cost savings compared to A100 P4D, and with V100 it's up to 61%. And on the BERT Large, the gap is a little smaller for A100's 12% savings versus the 59% savings with V100. we've run these experiments with the software stack that's available on the NGC and on our Habana walls. So it's something that you can reproduce yourselves. We also talked about having Gaudi available on premises. Gaudi is driving these same efficiencies on premise. This is one of our first public installations that you've heard about. The San Diego Supercomputing Center is deploying the Voyager cluster in fall. It has Supermicro X12 Gaudi servers that are being used to power this cluster. There are 336 Gaudi training processes in this cluster. And we are working very closely with them to bring it up, and it should be available for AI researchers across doing experiments and developing new capabilities with deep learning training on science and engineering domains. And we're really excited to partner with them to showcase what Gaudi can do here. So if there is interest, we can definitely reach out. In addition to our cloud instances, we also have Supermicro X12 Gaudi servers available, and you're welcome to contact Supermicro for additional details. I told you about the developer side. I'm going to spend a couple of minutes introducing you to our developer side, so you'll have an idea of what's available. We would love to get feedback, and if there are things that we should be improving and or add additional content, let us know. So when you enter our developer site, developer.habana.ai, you will start on the left side with the simpler getting started resources, which is a panel which shows you what are the documentation available. This is all of the documentation on the SynapseAl releases we have, and how user guides and very detailed release notes, installation guides. All of this is available on our docs website. On the software setup and installation, we have a GitHub repo with detailed instructions on how do you install the latest software stack, both for setting up on AWS DL1 as well as for on-premise. We have our Habana GitHub, which I'll talk about in a minute. In terms of the models that we have enabled, the data for those model performance is also available on our developer page. On the resources, we have information on how to get started with Gaudi, specific information on what you need to do to get started with the DL1 training instances. We have simple tutorials, which we've adapted for Gaudi. We have details on how do you do TPC programming, how do you get started with debug and optimization. There are also simple, like getting started videos available, which are small nuggets that you can consume a few minutes at a time. So we want to make it very simple for you to just start with Gaudi and then build up from there as you start adding more. We'll have more advanced content also available. So there's a variety of complexity in the content, and hopefully you will find what you need on our developer pages. I'm going to spend another minute on our GitHub. So when you go to the Habana AI GitHub, you will find that there are several. I've highlighted the top few here. There's a model references repository, the setup and install repository. There's also our SynapseAl roadmap repository. So the model references repository is where we've got our deep learning training examples. There are over 20 popular models for TensorFlow and PyTorch that the Habana team has spent importing over and basically publishing all of the model scripts and detailed instructions on how to reproduce these for yourselves. We hope you'll find it useful, and you can go in and these are just example references for you to get started. So you can then bring also additional models that you've built yourself and then port them over, and these will be sort of your baseline examples to start with, and you can refer to our migration guide after that. I talked about earlier the setup and install repository, which has all the instructions for getting started. There are also actual Docker files available if you want to build your own Docker. So there's a lot of information on like navigating the setup and installation process with the Habana Gaudi devices. There's another repo called Habana Custom Kernel, which has examples of how you would create your own custom kernel, and then how you would register a custom op with either TensorFlow or PyTorch, and then you can hook it up into your workflow to use these custom kernels. And lastly, on the SynapseAl roadmap, it just shows the work that we're planning, especially in terms of our model roadmap and an indicator of our operator coverage. You'll see information on what we're working on, and over time we will be adding more models. We would love to get your feedback. Before I hand off to Yuting, I wanted to kind of give you this little teaser in terms of what does it really take to get started. Here's a simple MNIST example. The main thing that SynapseAI is doing is it's taking that computation graph from the framework, extracting the subgraph that can be accelerated by the Gaudi devices, and then offloading it to the Gaudi. So all you need is those 2 lines of code, and we will show you examples of this actually in action. When you load these modules, the load Habana module and invoke it, this registers the Habana devices with the framework. These Gaudi devices are called Habana processing units, HPU, in the framework. So you'll hear the word HPU to refer to the Gaudi device. And once this is loaded, the HPU is basically preferred in terms of offloading the operator. If an op is available and can execute on the Gaudi, then it'll be assigned to the HPU. And then if it is not, it will fall back to the CPU. So now we want to switch over to the live demo, and Yuting will basically walk through, how do you monitor our Gaudi devices with HLSMI? How do you, just walk through a ResNet 50 and BERT demo with TensorFlow and PyTorch. He'll walk through some of the code changes. So I'm handing it over to Yuting, and we'll take it from there. Yuting.
Good morning, everyone. Again, welcome. So today I'm going to show you how easy it is to porting the deep learning models to run in Gaudi. So I'm gonna start from how to launch the AWS DR1 instance in EC2. Then I will show a couple of model training examples. One is ResNet 50 TensorFlow. Another one is PyTorch large fine tuning. So while the demo is running, I'm gonna navigate you through the GitHub page of our reference models. And if time allows, I will also guide you through the documentation and web pages. Okay, so once you have this task or project you want to use Gaudi instance, where you to start? So basically you go to AWS website. So this is what I'm showing here. I logged into our account, so your account may be slightly different, but mainly I show you the EC2 dashboard, what is running and what you want to do. So start from scratch, you may launch a new instance. So you can choose launch instance. So it gives you all the choice of available armies, right? So what we do here is we choose Habana. Okay, you will see here, we have like 6 results in marketplace and also 26 in community. So those 6 in marketplace is actually published by Habana. And then the 26 is published by AWS. So those published by AWS is called Habana DR Army. So we have different kinds of DR armies, right? So for those published by us in marketplace, it's called a base, right? You may ask, what's the difference between the base army and the Habana army? So the difference is base army only has the driver firmware installed. So if you want to run in the OS environment, you have to install other components like a framework. But if you want to use Docker, then it will be much easier. Everything already included in the Docker image. And so in this example, we are going to use the Habana base army. So let's take a look at what do we have here. Okay, so we have base army for I think 3 or 2 OS, Ubuntu 18, 20, and Amazon Linux 2. So we also have like EKS, which is AWS Kubernetes platform, and also we have the ECS. So for the demo today, I'm gonna only show those base armies. So for the Kubernetes and others, maybe in the future we can have other webinars. Okay, so I choose this one here, Ubuntu 20 base army. Okay, now it's pop out the pricing for and also some description of this army. So I choose continue. Okay, so now you go to the page where you want to choose instance. This is where you need to choose DR1 instance. So I pick it here. You can see DR1 instance. So there's multiple terminologies. You may get a little bit confused. So we call this Habana Gaudi based DR1 instance, right? Gaudi is a product name and the DR1 is an instance name here in AWS. Okay, so we only have one choice today. So it already give you 96 vCPU and also 768 gigabytes host memory. So we also have the high-speed SSD. And also we have the high-speed host NIC connection between multiple hosts. So after that, I think the steps are similar to you running any other instance in AWS, right? So in this example, in this step, you choose the VPC, right? So you can pre-create and then choose the existing one. You can choose also choose create a new one. Right, so one important check is you need to enable the public IP. So in most of the case, you're going to use this public IP to access. Okay. So next step is to add the storage. By default, it already gives you the root and also for NVMe SSD. But keep in mind that this for SSD is temporary, so it's physical connected to the instance. But since AWS is like virtualized platform, so when you log in next time, you launch a same instance, it can be physically different one. So this for SSD can be different too. So your content will not be there anymore. So the recommendation is you need to copy out either to S3 or other like a permanent volumes. So another tip here is you may want to add a volume for your data set for your training, right? So that is the way you can share your data set for multiple instances. Instead of you have to upload the data set to each instance one by one, okay? So you can couple this volume with a snapshot. A snapshot is where you keep the data set instantly. So each time you can snapshot to the volume, then you can mount the volume in your instance after you launch your instance. Okay, so add a tag. So this is like normal. For example, you can choose add a name so that you can remember which instance it is, right? Then the next step, I think that should be the final step, is to set the security group, right? So if you choose create a new one, the minimum thing you need to do is to enable SSH access, right? So what you do is just put it here, say allow SSH, and then put my IP. So with this, if your like IT department did not put any firewall, so this should work already, right? So the last step is review and launch instance and guide you through all this. So if you click this button launch, so then AWS in the background start to pick up the existing physical instance and start a boot for you. So in my case, it's gonna take like a couple of minutes for the instance to start running after you click the button. In my instance, I already have the instance started before the training. So what you need to do here is first check if it's already, check its current status, right? So if the status is running and already passed the AWS checks, that means it's ready to log in. So how to log in? You just click here and look at this connect. So it will tell you those information, instance ID, which you may use later in your like billing. And the most important step is give you the public IP address you can use to log into an instance. So you can copy and paste. Okay. So now I'm go to my console in my laptop. I'm ready to log in. So I don't know about you, but for me, first time when logging, I'm a little bit nervous and also a little excited. So let's see what will happen here. Okay, so we'll ask you some like security related questions after that. So now you are in the DR1 instance in AWS. So after you log in, you may ask, oh, okay, this is Gaudi-based DR1 instance. Where's Gaudi? So we do have a small application you can use to watch the Gaudi status, or the HR SMI. Okay, so it can show you the snapshot at this moment. It can also show this in a loop. So now you can see we have 0, 1, 2, 3, 4, 7, total 8 devices here. So it's called HR205. I think this is our code name for Gaudi. And it also show you the power consumption and also show you the memory consumption. Since now the training is not started, right? So we have lower power consumption and also we only use half giga among 32 gigabytes HBM high bandwidth memory in each Gaudi. Okay, so it can also show you the process running. We use the single process, single device model. So each process control one Gaudi. Now, none of the processes running yet. Okay, so now you show this Darwin instance. You have 8 Gaudi available for you. So what do you want to do? Usually it's I want to run some example models. So this is where you get all these example models. So Suli already showed these pages. Let's click next level to take a look. So we have TensorFlow, we have PyTorch. So if we click TensorFlow, we can see we have computer vision, we have NLP, and we also have some examples. So I will navigate you through this web page, GitHub pages later in details. But now let's kick off the training. Okay. So I'm going to show you the RANT 50 QLAS model running in 8 Gaudi. Okay. So the step is very simple. Since we are using a Docker, so basically you put in the Docker and you run the Docker and then you kick off the training. That's it. So let me do a live demo now. So, first step, remember I mentioned that we have some data set which already preloaded, right? So you can use this command ls block to see. So I actually put the data set in this NVMe device. So remember this one. Then what I need to do is mount this. Okay, so it's mount this to my data folder. Okay. Okay. So after this, you will see. Let me see. Okay, so I have this ImageNet and some other data set there already. Okay, so the next step is to pull a Docker image. Okay, so this is command we are running. So Docker pull. So this is a path to our Docker image. So it's called vault.habana.ai. This is our container repository, right? So we can go to that website. It will show you multiple versions of release and also for multiple OS support here. So we choose the latest one, which is 1.1.1. Okay, so looks like I already have a Docker pull in this instance. So it's just telling me it's up to date. Okay, so now we already have the Docker. The next step is to kick off the Docker run. Okay, so here is a couple of parameters we set for the Docker run. So Docker run name. So this is a standard Docker parameter. So you choose TensorFlow demo, which I call it. Then you choose it's interactive mode. So one thing special here is the Docker container runtime. So we have our implementation of the container runtime called the Habana container runtime. So with this runtime, it will make the management of those devices easy. So for example, you only need to define visible device equals to all to use all the 8 Gaudis in this instance. You can also define 2, 4, or 8, and some other numbers. So without container runtime, you have to like expose all the device in this container, which may bring some security issues, right? Then others is like a standard Docker run parameter. So only thing here specific is I define the path. So I need to mapping the data folder in host to the Docker images. So when you do the training, you can inside the Docker, you can use this data set. Okay, so that's it. Okay, so now we are inside of the Docker image now. So the next step is to get the source code. Okay, so this is our GitHub path. So you can define version. You can define a version. This is the latest version, 1.1.1. So it will clone the code. Okay, that's it. It's very fast. This is all source code. So the next step is to set up a Python path. Basically, put the model reference in our in the Python path. Okay. Oops, sorry. Okay, so that's it. This is all you need to do to kick off the training. So let's go to the folder where the rand 50 is. So it's in the model reference, in the, I think it's in the TensorFlow, in the computer vision, and in the resonate. Okay, so I think it's in the resonate class. Okay, so now I'm gonna have the command line for you to kick off the training. Okay, so this is a command line. This is a script we made to make the training run simple. Eventually, it will translate into the MPI run to launch multiple process for multiple Gaudis. Okay, so all these parameters were passed down either to the script or to a source code. So, for example, we define bflow16 as a data type. We use the same data type for data loader, and we use Holloword to do the distributed training here. And also we define how many workers we want to run, which is 8 here. So the 40 means we run 40 epochs. Another 40 means we want to do the evaluation after the 40 epochs, right? So evaluation before epochs before evaluation. So we choose batch size 256, and also we choose last optimizer. Okay. So now let's kick off the run. So while we are watching this, so it's gonna take several iterations or several mini steps for the performance to get to a constant value. Let me navigate you through our model reference page here. Okay. So this is the examples and also existing models. So let's, for example, goes to computer vision. You can see the models we already enabled with performance and accuracy. So we have about like less than 20 models, more than 10, less than 20 models here. So the one we are running is rand 50 and the KRAS model. Okay. So in this GitHub page, you will see we describe the model a little bit and also show you how to set up. This is mainly for you to get the environment ready. But if you use Docker, then probably you can skip this step. Then most important part is the training, right? So you can see here, those command is what I just run to kick off the demo. Git clone and then go to that folder and then set the path. Okay. So the next section is about multi-chassis or multi-host training. So we do support a scale out of a single box in AWS. Use the Libre Fabric there. So we may have like a deep talk about that. So today we are going to skip this part. Okay, then we go to how to running the model. Okay, so we have one simple thing. Script is this demo rand KRAS model. And so those are the arguments you can set in this script. So I already described a little bit of them, so you can look at by yourself. So here's some examples. What do you want to do? You can choose bflow16, or you can choose FP32 as a data type as default, right? You can also run 90 epochs or 40 epochs. You can choose different optimizers, okay? So we also have some like a modified community script, right? So this is a little bit complicated. You need to eventually run the MPI by yourself. Okay, so we can see here, so the training is already started. So this is in the 50 steps. So this is ImageNet, right? So we have like 25,000 steps. Then for each total for 40 epochs, and for one epoch it's maybe 65. So sorry, 600 something mini batches. So we are waiting for this throughput to get constant here. Okay, so now since we still have time, I'm going to show you in the code level what kind of change we need to do to porting the model into Gaudi. Okay, so we have a folder contains this kind of information in GitHub page. Okay, so let's start from hello world. Okay, So Hello World is as any like a programming language or a library, right? So show you the simplest examples. So the first one is a single Gaudi training. So you can see this is an MNIST model, Sri already mentioned. So I just want to show you in the source code level what change we need to do, right? So in the line code 3 from Habana frameworks, TensorFlow import load Habana modules. So this is a function which offload the tensor and the computation to Habana device if Habana device support this op. Okay, so Habana device is implemented as a plugin to standard TensorFlow framework. So it will feed back to the framework what kind of op we supported. So then once framework gets this information, when it gets the op, it will do the dispatch accordingly. Either goes to HPU or Gaudi, or goes to CPU if Gaudi doesn't support this op, right? So all other code is the same as like the code running in CPU or running in GPU. Okay, so now I'm gonna show you another example, which is running the distributed training use 8 Gaudi within a host. So we support two kinds of scaling out methodology. One is Harvard based, another one is a TensorFlow distributed training, right? So this example is Harvard. So the line of code need changed is all in first 5 lines. So the line number 2, we need to load we need to import load Habana modules, same as a single Gaudi, and we need to call this function. Okay, and then after that you need to import Harvard. Okay, so this is Habana implementation of Harvard. Okay, and then after that you call Harvard init. So then this from line code 9 to 15 is where you do the data partition among multiple Gaudi instance. Then the remaining code is the same for all code running CPU or GPU, right? So now we do have a requirement you call load Habana modules before import Harvard, but we are going to relax this requirement after in the future release. Okay, so now we can. I want to show what I want to show is the how you can watch the Gaudi status while training is happening, right? So what we're gonna do is we open another window. So let me log into this instance again. So let me go back to this. Okay, so while the training running, I can log in from another terminal, right? So then I will run HSMI in a loop mode. So it will show you the status in a loop. So now you can see here, all the memory, the high bandwidth memory is already occupied because training is ongoing. We can also see the power consumption goes up. Okay, so I can show you. I think I need to run this. Okay, so if I sudo, it will give you the host process info. Okay, so while leave it open, I'm going to navigate you through some other examples as well. So today AWS provide you only one kind of instance for Gaudi, which is 8 Gaudi instance, right? So sometimes you may thinking you have multiple model you want to run. Maybe each one, the small one, you don't have to use all the 8 instances. So you want to doing multitasking. You want to train this model in parallel. So how you can do that, right? So here I provide an example called multitasking. Okay, so it's actually very simple. So the key here is you need to define this environment variable called HRS1 module ID list. So it starts from 0 to 7. So we recommend, for example, you run 2 Gaudi or 4 Gaudi, right? So if you want to run the 4 Gaudi, the first 4 Gaudi, you can define 0, 1, 2, 3, 4. If you want to run the 2 Gaudi, you define 0, 1. And then you can, but make sure you assign your model to different Gaudi numbers here, right? So this is how the script looks like. So you can see here, eventually this script is calling into the same script I was running now. So demo rent keras.py. Okay, so only thing you need to do here is basically according to the Gaudi number you provided. It gives the this parameter the total number you want to run. Okay, then this environment variable will be passed down to our low-level software, so they can assign the workload to the Gaudis accordingly. Okay, so I think this may be a useful feature for you. So now let's go back to our training here. Let me stop this. Okay, so now I think it's the throughput goes to a stable stage. So we can see here it says steps per second is 6.38. So I'm not very good at math, so let's calculate what does that mean with as translated into an image per second. So this is a global steps per second, but for each Gaudi. So if it's 6.38 for each Gaudi, then times the batch size is 256. Then times total 8 Gaudi. Okay, how many we have? We have 13,066. So this number is aligned with what we published in our performance page in GitHub, right? So 13,066 images per second. Okay, I think this is a demo for the Resident 50. So I think we still have time. I'm going to show you another demo, which is PyTorch large fine tuning. Okay, so let me stop this one. Okay, so let me quit this Docker. Okay, now I'm go back to the OS in the AWS DR1 instance. So similar to the TensorFlow PyTorch, we provide a separate Docker image. So you can Docker run, Docker pull and Docker run. So what do we do here? Is I combine the Docker pull and Docker run together. Okay, you can see here same parameters use the Habana container runtime. So only difference is the path to this Docker image is different. Previously is PyTorch. This one is TensorFlow. So previous one is TensorFlow. This one is PyTorch. Okay, so now again we go inside into the Docker image. So similarly, you need to since this is a new Docker image, you need to clone the source code. Okay, so after you clone the source code, what you need to do is similar, add the model reference into your Python path. Then for the PyTorch, we need to do one extra step, which is data set. So we so with this, I think for PyTorch BERT large fine-tuning dataset, I don't have to download it by myself. During the training, it will automatically download it for you. Okay, so now we are ready. So the last step is to running the model. Okay, so let's look at this command closely. So we define this is, oh, I think I have to go to that path first, sorry. So this model garden, PyTorch. We can see what we have on the PyTorch. We have computer vision, we have NLP. So BERT is NLP. Let's go to NLP. Then we have BERT. We have some other variant of BERT. Okay, so now we are in the BERT folder now. So I'm gonna kick off this one. Okay, so for BERT, we can do either fine tuning or pre-training, right? We choose BERT large, so the other choice is BERT base. So we run in the lazy mode. So you can also choose in the eagle mode. So data set, we are using squad, right? So others is, oh, okay. So we use batch size 24, sentence length is 384, and this is the learning rate, and also we're gonna do the eval. Okay. Okay, so since this is fine tuning, so it's gonna take some time to download the pre-trained the checkpoint and also download the data set, then it will start to do the fine tuning. Okay, so similarly, you will find that those models and the examples in our GitHub page. So model reference, PyTorch, we have computer vision, we have NLP, we have DRM. So I think in the near future release, we'll also add like Hello World kind of example here for PyTorch. Okay, so I think this is the where I talk about the GitHub page. So while waiting for this fine tuning get to a stable throughput, I may quickly go through the our documentation page with you. So you can see here docs.habana.ai. So we put all the documentation here, and you can find, for example, a TensorFlow user guide. So this will explain to you our mechanism to support the TensorFlow framework and what you need to do to enable your model running in Gaudi. Okay, so similar for PyTorch, we also have distributed training. So it covers Harvard and HPU strategy, TensorFlow distributed use HPU strategy. So we also have some useful tool like HR Core. Oh, I think most important part we also one important part is we also have the TPC. So this is the part where you can do advanced programming to programming kernel to be used as a customer kernel and custom op in training. Okay, so let's see. Maybe let me mention one thing here. In our distributed training guide, so what I just showed you is in the Hello World kind of toy model, how to make the change. So here we actually list the change for rent KRAS model, rent 50 KRAS model, what change we add in order to enable distributed training. So let me bring this one to you. A lot of stuff here, so I will leave you guys to take a look if you are interested. I just quickly go through some part I think is important. Okay, so here it is. I'm sorry. Okay, here, this is the one. Okay, so KRAS rent 50. Okay, so all the changes here. So you can see we need to import Harvard as we did in the Hello World. So in our the GitHub page, we implement a library called Harvard helper, right? So this wrapped some code you see in the Hello World, just make your life easy, right? So this is where, according to the flag, and they do the data sharding, right? So basically, you need to get to the Harvard the size and the communicator size, and also your rank. Then we will get your corresponding part of the data set. Okay, so this is where you define the flag. I think the key thing here is to you need to do the adjust the batch size. Okay, and since we do the what do we call the weak scaling, not strong scaling. Okay, and okay, so I think this is where you So this is where you import this library. You need to calculate the global batch size, or maybe I make it bigger so it will be easy to see here. Okay. Yeah, I just want to quickly show this the code change you needed in order to, so this is where you set the path, and also you call the hardware init. So when a part is for the evaluation, you can also enable the distributed evaluation by insert or reduce call. Okay, so now let's go back to the training page here. Okay, I think we already get a stable status. Where is the performance here? Oh, it's here. So it's 1.88. So let me do the math again quickly. Okay, so this is 1.88 times batch size 24 times 8 Gaudi. So it's about 360 sentences per second. Okay, so this is our both large fine-tuning performance. Okay, so I think that's all I want to show today. Thank you.
Yes, thank you. Thank you so much, Yuting and Sri on that. We do have a few minutes left to do questions. So if you could go to the Q&A section and go ahead and put in any questions that you might have. And if we don't get to them, we could go ahead and give our email address for you to ask us questions. So there's one that says, what are the patches and PT Lightning is the code of the patch version on GitHub?
Sorry, yes. So we are working with the PyTorch Lightning team to upstream the changes. We had to fork the code to integrate Gaudi with PyTorch Lightning. So you'll be using for now a forked version, and then shortly, once we finish upstreaming the code, you should be able to take the latest versions from PyTorch Lightning's webpage, the GitHub.
Perfect. Thank you. There's another one. Are you planning to support Julia language in the future?
Not at this moment, but we can certainly take that request back and put it in our backlog. Thank you.
Okay, let's see. This one says, can I run less than 8 Gaudis?
Yes, I think I already show the example in our GitHub page. So basically, you can define how many Gaudis you want to run, and also you define which Gaudi you want to use through an environment variable. Then it will use that amount of the Gaudi. So remember, define like a sequential number. Don't overlap with each other. You can define 0, 1, 2, 3 for one task, and 5, 6, 7, 4, 5, 6, 7, and another task, but don't define 0, 1, and then 1, 2. Then it will have conflict.
Okay. Okay, there's one more. Is it possible to test the most part of the setup on a local machine that has no HPU to avoid cloud tinkering at first?
I think so. This is what we do before we get to the physical instance, right? So I think the whole installation can be done. The earliest point you will get a failure is when you're trying to run the training. So then it will fail at acquired device. So I think all the setup should still work. But we never tried that. But yeah, you can go ahead and try. But I think it should work.
Okay, I'm going to ask one last one since we're at time. And then for the rest of them, I'll give you an email address for you guys to reach out to us. So this one is, do you have support for Kubernetes?
Yes, we do. So as I in the beginning showed the AWS instance type, right? So we have EKS, and so it is available in AWS. Our support as a for Kubernetes is implement a plugin, so it can be deployed in either in EKS or in the normal like on-prem data center Kubernetes environment.
All right, guys, I know we're at time and there's more questions coming in. The email address where you could reach us to ask any additional questions and we'll respond to you is info@habana.ai. Please feel free to send us any questions and we'll respond to you. We want to
actually, Pauline,
yes.
I would like to suggest that if there are more questions, I would encourage folks to ask them on our Habana forum. So that way they get more, there's benefit for other users in the community as well. So please do go to our Habana forum and ask questions so we can service the larger Gaudi developer community.
Yes, great point. Thanks for that, Shri. So we want to thank you for attending this webinar. As we all mentioned at the beginning, this is our first one. We do look for feedback and any suggestions for future content. Please let us know. If you have any additional questions, email us at info@habana.com and visit the developer site. And also, as Shri mentioned, please go to our forum and ask any questions you have there. Thank you so much for attending, and we appreciate all of your time and working with you. We look working with you with Habana. Thank you so much. Have a great day.